Good day, everyone, and welcome to Learn with Mike. So, for today's topic, it's about Avogadro's Law. Let's start. Avogadro's Law. It describes the relationship between the volume and the number of moles of gas, proposed by the Italian chemist Amedeo Avogadro. So, this is Avogadro. So, this law states that equal volumes of gases at the same temperature and pressure contain equal number of molecules. Or we can say that in Avogadro's law, the constant is the temperature and the pressure. And what we are talking about here is only the volume and the number of mole. Or we can say as the volume of gas increases, number of moles also increases. So they are directly proportional. So in Avogadro's law, this is the formula. V1 over N1 is equal to V2 over N2, where V1 is the initial volume, V2 is the final, N1 is the initial number of mole, and N2 is the final number of mole. Let's have an example problem. Number 1. 5 liter of gas is known to contain 0.965 mole. If the amount of gas is increased to 1.80 mole, what new volume will result at an unchanged temperature and pressure? So, let's write the given unknown in the solution. Given, V1 is 5 liters, N1 is 0.965 mole, N2 is 1.80 mole, and the unknown is the V2 or the final volume. For solution, V1 over N1 is equal to V2 over N2. Substituting the values, 5 liter over 0.965 mole is equal to V2 over 1.80 mole. Cross multiply, copy V2 and 0.965 mole, then multiply 5 times 1.80 mole is equal to 9 mole liter. Then dividing both sides by 0.965 mole, cancel, then the answer is 9.33 liters for final volume. Analyzing the values, for volume from 5 to 9.33 liters increases, and for the number of moles, 0.965 mole to 1.80 mole increases also, because they are, again, directly proportional. Number 2. A flexible container at an initial volume of 5.120 liters contains 8.50 mole of gas. More gas is then added to the container until it reaches a final volume of 18.10 liters. Assuming the pressure and the temperature of the gas remain constant, calculate the number of moles of gas added to the container. So let's write the given. V1 is 5.120 liters, V2 is 18.10 liters, and 1 is 8.50 moles. Unknown is the N2 or the final amount of mole. So for the solution, V1 over N1 is equal to V2 over N2. Substituting the values, 5.120 liter over 8.50 moles is equal to 18.10 liters over N2. Cross multiply. So N2, then 5.120 copy is equal to the product of 18.10 and 8.50, which is 153.85 moles liter. Divide both sides by 5.120, cancel. Then the answer for N2 is 30.05 moles. Analyzing the values, volume from 5.120 to 18.10 increases, and for the number of mole, from 8.50 to 30.05 moles increases also. Number 3. A 2.7 mole of gas has a volume of 2.9 liter at certain temperature and pressure. Find the new volume of this gas if 5 moles are added to the original volume under the same condition. So please take note of the words if 5 moles are added. So let's write the given. So V1 is equal to 2.9 liters, N1 is equal to 2.7 moles, and for N2, like what the problem is saying, by adding 5 moles to the original, which is 2.7. So N2 is equal to 2.7 plus 5 moles is equal to 7.7 moles. And the unknown is the volume or the volume 2 or the final volume. Formula, substituting the values, 2.9 liter over 2.7 moles is equal to V2 over 7.7 moles. Cross multiply, copy V2 2.7 moles, then product of 2.9 and 7.7 is 22.33 moles liter. Dividing both sides by 2.7 moles, cancel, then the answer is 8.27 liters. Analyzing the values, volume from 2.9 to 8.27 increases. Number of mole from 2.7 to 7.7 moles increases also. And now for our last problem. A balloon containing 2 moles of helium has a volume of 0.8 liter. What would the volume be if 3.5 moles of helium are added to the balloon? So that is the, not he. So, given V1 is equal to 0.8 liter, N1 is 2.0 moles, and for N2, 3.5 moles is added. So from 2, then add 3.5, the answer is 5.5 moles. And the unknown is V2. Formula V1 over N1 is equal to V2 over N2. Substituting the values, then cross multiply, copy V2 and 2, then multiply 0.8 times 5.5. The answer is 4.4. Divide both sides by 2 moles. Cancel 2 moles. Then cancel the unit moles on the right. The remaining unit is L. 4.4 divided by 2 is equal to 2.2 liters. Analyzing the values, volume from 0.8 to 2.2 increases. And for the number of moles, from 2 moles to 5.5 moles increases also. And let's proceed with the application of Avogadro's law in real-life situation. So these are the examples. Number 1, a flat tire takes up less volume than an inflated tire. Number 2, as you inhale, your lungs expand as they fill with air. As you exhale, your lungs decrease in volume. Next, number 3, a helium-filled balloon weighs much less than an identical balloon filled with air. Next, number 4, moist air is less dense than dry air. So, thank you for watching. That's all for now. Subscribe if you learn. Thank you.